What's up guys, it's Talha here again, and today we are going to discuss our statistics paper which we took last week. So in this statistics paper, we had 20 objectives. No, I think we had 10 objectives, each carrying 2 marks, so that makes a total of 20 marks. And then we had a subjective part where we were supposed to do we were supposed to do 5 questions in total, and we had 2 problems in that subjective paper. One was related to binomial theorem. One was related to binomial distribution, and one was related to hypergeometric distribution. So we are discussing today our statistics final paper. And in that paper, first we had objective part, which had 10 objectives in total. 10 MCQs in total, and each carried 2 marks, so that makes a total of 20 marks in objective. And then we had 30 marks in our subjective paper. And in those 30 marks we had 6 questions, and we had a total of 3 questions, and we had two subparts of those three questions, mean A and B. So the 2 parts combined, so if we count one as 2, so we are left with a total of 6 questions, and that completes our 30 marks, and 30 plus 20 equals 50. So our first question in the subjective. So in objective, there were questions. For example, the first objective was to you had the probability given. So you had 0.3. So the first objective asked us that what is the variance when the probability is 0.3, and the n means the total number of trials is 10, and what is the variance of binomial distribution. So as we know that the mean of binomial distribution is n multiplied by p. So when you find the mean, so you can say mu equals n into p, and this implies 10 into 0.3 is, so our mean is 3. Now for variance of binomial distribution, we have a formula. Variance, or sigma square, equals n into p into q, or you can say n into p into 1 minus p. So if you calculate 1 minus p, if you calculate the q, it's going to give you 1 minus 0.3 is going to give you 0.7 multiplied by 3, and that gives you 2.1. So 2.1 was the B option, I think. So this was the variance of that binomial distribution. And we had similar objectives like these. For example, we had an objective where we were supposed to write where we were supposed to circle the correct option of how many parameters does binomial distribution have. So for binomial distribution we have 2 parameters, and for hypergeometric we have 3 parameters, not 4. We have 3 parameters for our hypergeometric distribution. And the rest of the objective, I don't exactly remember every one of them, but every objective was like this. And in the subjective part, so coming toward the subjective, we had 6 questions in total, and there were a total of 3 questions, each having subparts A and B. So for subjective paper, our first question was to differentiate. Our first question was asking us to differentiate between frequency distribution, and our binomial and our probability distribution. probability distribution. So it was asking us to differentiate between these two types of distribution. So in a frequency distribution is related to your sampling distribution, in which the random variable or the statistical term is written on the left side and the corresponding probabilities are written on the right side. So it's related to sampling distribution. So here so whenever you come across this term known as the frequency distribution or sampling distribution, so here you just have to remember that on the left side you have a random variable, or you can say the statistical term, and on the right side you have their corresponding probabilities written. So what is sampling distribution or the frequency distribution? It just helps you to make an inference about the population. So for example, if you have different samples and you take a sample of size, for example n equals 2, and you want to calculate the certain statistical term. For example, let's say that you want to calculate the variance of the population, but you don't know the population, you just want to make an inference about it. So what are you going to do? So you have to consider samples for to inference or to guess the population of the to guess the population. So what you do is you calculate samples, you calculate the statistic of samples, you distribute them, means you perform the process of sampling distribution, and that way you're going to make an inference about the population, and you can say that on the average, so what you get from the sampling distribution of certain statistical term, you can say that on the average the population has the same statistical average, or you can say has the same value of the statistical term you have just calculated. So in frequency distribution, for example you want to find the frequency distribution of, for example, let's say mean. So for mean you have the formula mu of x bar equals mu. So that means when you perform the sampling distribution of mean, you get the exact same mean of the population. For variance of x, you have sigma squared divided by small n into capital N minus n divided by capital N minus 1. So using this process you're going to make an inference, and you're going to get your variance for your population using the sampling distribution of variance for these samples. So this is a formula for the mean, and this is the formula for variance. Now what are probability distributions? Probability distributions are the distributions where you distribute the probabilities of a certain random variable based on the value of certain random variable and what type of that random variable is. So in probability distribution you distribute the probabilities over all the outcomes, and based on the value of the random variable and the type of the random variable. So for example, I say that for discrete random variables, so you have two types of random variables. You have discrete random variables and you have continuous random variables. So for discrete random variables you have probability distributions known as binomial, you have hypergeometric, you have Poisson distribution, and when you come across a continuous random variable you have uniform distribution for your continuous random variable. So for continuous random variable you have uniform distribution, and for discrete you have binomial, hypergeometric, and Poisson distribution. So depending on the type of the variable and the value of the variable, you have different probability distributions for different kinds of or different types of random variables. Now in the B part, so this was the A part of our first question. For the B part, we were given to in the B part we were given a problem where we were supposed to calculate the binomial distribution, where the formula for the binomial distribution is when p of capital X assume little x, you have n choose x, then you have p means the probability of success to the raised to the power to the number of successes, and then you have q, which is also known as 1 minus p, so the probability of failure raised to the power of number of failures, so n minus x. So this is the formula for your binomial distribution. So utilizing this formula, you were supposed to solve the problem in the paper. So in the paper, you had given the probability, you had given the n, and you had given the x. So what you were supposed to do, you were supposed to put the exact same values in this formula, and also it was for, I think, if I remember exactly, you were to find the probabilities when x assumes was 0, I think 0, 2 and 6. I think it was like this. So you had to find the probabilities of these three. So when x assumes these three values individually, you had to find the binomial distribution for their individual uh, values that capital X assumes. So I don't exactly remember the values for the probabilities in n, so I'm just going to skip this. You can do it by yourself. You just have to plot the values and you'll get a result that will be your binomial distribution for specific values of the random variable. Now for the next question, what we were supposed to do is we were supposed to write the properties of hypergeometric distribution. So we had to write the properties of hypergeometric distribution. So what are the properties? First property is that you have two outcomes, that is success and failure, because it is a discrete random variable. So you can it has got to be the Bernoulli distribution. Bernoulli variable or Bernoulli distribution is any type of variable which can have only two outcomes, means success or failure. Oh, sorry, you can say that Bernoulli trials are the trials which can have only two outcomes, success and failure. So you have success and failure. Hypergeometric random variable and distribution can have only two outcomes. Next, the experiments or the trials are dependent on each other, means that the probability of one trial depends upon the probability of another, means one trial is not independent. For example, if I say the for hypergeometric distribution, for example, if I say that there are 4 balls in a container, in a box, I say that there are a total of 4 balls, and 2 are red and 2 are green. And if I tell you that so what is the probability of taking out the ball and its color is red? So that will be 50%, because 2 by 4 is 50. But what if I take out one ball and I do it without replacement, means that I don't replace the ball again in the container? Then what will be the probability of the red balls in the container? Well, now there are only 3 balls, so that will be 1 by 3, and that will be so 1 by 3 is equal to, I think, 25 something percent. So the probability is decreased, and the probability is now different from what we had earlier. So that is what is meant by a dependent and independent variable, where one trial, or the probability of one trial, depends on the probability of another trial, or one trial depends upon another trial. Next, you have in hypergeometric distribution, you have experiments, you have trials without replacement. So that's the main difference between a binomial distribution and hypergeometric distribution, that in a binomial distribution you replace every item with each trial, but in hypergeometric you don't. So there's a difference. And also in hypergeometric distribution, you perform the experiment n number of times. So the number of trials, you can say, are fixed in hypergeometric distribution. So this is pretty much it about the properties of hypergeometric distribution. And in the B part of this question, we were given the a problem to solve. So the formula for hypergeometric distribution is when P of capital X assumes little x, you have K. I'm going to explain this each term separately. I've also made a video by the way on binomial distribution, hypergeometric, and every one of these topics, but in these during this week we are just discussing the papers which we took last week. So I've made separate videos for each of these topics in detail, so you guys can go and check them out if you have any difficulties. So you have P of x equals k. So k is your number of total successes in an experiment, divided by x, which is your interested number of successes. So this is going to be given in the question, which means that this is the number of successes you're interested in, and k is your total number of successes. So kx, when k choose x, you have n minus k, which is the number of failures, because n is the total number of items and k is total number of successes. So when you subtract it by the total number of items, you're going to get total number of failures. And n minus x, n is your sample and x is your interested number of successes, so that is going to leave you with n minus x is going to leave you with the interested number of failures, divided by n, capital N, choose small n, means total number of items, choose sample. So you had given the values of each you had given the values of each parameters in the question, and you just had to plot the values here in the formula, and then you get what you want, that is the probability when x assumes a certain value, and you have the hypergeometric distribution for the respective values of capital X. Excuse me. Now after this question we had question number 3, and for the A part we were supposed to discuss binomial distribution. I wonder why sir did not give Poisson distribution in the question, because it was really interesting, and if it was there, it would have been really interesting if it was hypergeometric, Poisson, and binomial distribution, all three of them in the same subjective paper. But the teacher really just gave us binomial and hypergeometric distribution. I think the teacher gave us because there is a huge and the most important difference between binomial and hypergeometric, that in binomial you have independent experiments, and in hypergeometric you have dependent experiments. It is with replacement and it is without replacement. So that is why I think the teacher gave us these two. So we were discussing binomial distribution. So what we had to do, we had to define the binomial distribution. So it is a discrete probability distribution where when x assumes little x, you have n choose x. N is the total number of trials, x is your interested you can say number of outcomes, and p is your probability of success raised to the power of the interested number of means raised to the power of total number of successes. Q, which is the probability of failure raised to the power n minus x, which will give you the total number of failures. So and the properties, so we also had to write the properties of the binomial distribution. So the properties include, so it's the main difference between this and hypergeometric is the dependency and independency of the experiments. So in the properties you can say, so you have the same, you have the success and failures. So you have Bernoulli trials, in the binomial distributions as well. You have success, failures. Number 2, the experiments are independent, which is the main difference. Number 3, it is with replacement, and in hypergeometric case you had the experiments without replacement, so you have it with replacement. And number 4, the the number of experiments are fixed, so it is you can say you perform the experiment n number of times. So that was pretty much it about this question. And in the B part, you had to write a note on your study tour. So for the students who didn't go on a tour, you had to write the some comments about your statistic subject. For us, we went to Lahore, I think a month ago, or a couple of, I think a month ago, and we wrote pretty long stories about our tour. So I think the teacher will give equal marks to everyone, because this question was a general one, and the teacher shouldn't deduct any sort of marks in this question. So this question you guys don't you guys don't worry about this question. And for the rest of the questions, that were pretty easy, and that is what we just did. We solved the paper. Alright guys, I'm running out of time. I'll see you guys tomorrow, and tomorrow we are going to discuss our calculus paper. Bye bye.